Feature enhancement in visually impaired images. Improving the features of visually impaired image is big open problem in computer vision. Many algorithms are available for improving the features of visually impaired images. This paper deals with two different methodologies used for improving the visually impaired image. The first methodology is known as phase stretch transform. It improves the image by edge detection, image enhancement. The phase stretch transform is a newly introduced computational approach for image processing. But phase stretch transform can be applied by converting the color image to grayscale image. The next methodology is adaptive gamma correction. It enhances the contrast of the image with parameters set by adaptive gamma correction. AGC can be used in enhancing both color and grayscale image. It requires no conversion of color image to grayscale image. Keyword, AGC, PST, peak signal to noise ratio, maximum difference, normalized absolute error. 1. Introduction. In this digital world, digital cameras are becoming cheap and affordable to all standards of people. But most of the people are not aware of capturing a perfect shot using camera. These images are often affected by atmospheric changes, the poor quality of the image capturing devices, the lack of operator expertise etc. Since these factors are unpredictable and varies from place to place, user cannot expect a perfect image. This paper aim is to enhance the visibility of the important feature of the image after the image is captured by using digital image processing. Digital image processing is the use of a digital computer to process digital images through an algorithm. As a subcategory or field of digital signal processing, digital image processing has many advantages over analog image processing. To process a digital image, user must have basic knowledge on digital image. Digital image is nothing but a 2D signal which is defined by a mathematical function f, x, y, where x and y are two coordinates namely horizontal and vertical. In other words, digital images are made of picture elements called pixels. Typically, pixels are organized in an ordered rectangular array. The size of an image is determined by the dimensions of this pixel array. The image width is the number of columns, and the image height is the number of rows in the array. Thus, the pixel array is a matrix of m columns x n rows. To refer to a specific pixel within the image matrix, define its coordinate at x and y. The coordinate system of image matrices defines x as increasing from left to right and y as increasing from top to bottom. Since digital images plays a major role in medical image processing, satellite image analysis, texture analysis and synthesis, remote sensing, digital photography, surveillance, and video processing applications. So, digital image must provide the features of the object accurately or it may lead to misconception. This paper aims in extracting the features from a visually impaired image. One of important feature of digital image processing is image enhancement. Image enhancement is the process of adjusting digital images so that the results are more suitable for display or further image analysis. For example, user can remove noise, sharpen, or brighten an image, making it easier to identify key features. It is achieved by varying the features like saturation, sharpness, denoising, tonal adjustment, tonal balance, and contrast correction/enhancement. Some of the commonly used image enhancement techniques are histogram equalization, noise removal using a Wiener filter, linear contrast adjustment, median filtering, unsharp mask filtering, contrast limited adaptive histogram equalization, CLEHI, etc. B. Jolley et al. One proposed feature enhancement in visually impaired images explains about phase stretch transform is a physics-inspired nature algorithm, equalizes the input brightness across a range of intensities resulting in high dynamic range in visually impaired images. M. H. Ascari and B. Jolley et al. 2 proposed the motivation behind the algorithm is the observation that salient image feature points are often characterized by changes in local curvature, and the scale interaction model localizes such image information. M. H. Ascari and B. Jolley 3 proposed the output phase of the transform reveals transitions in image intensity and can be used for edge detection and feature extraction. M. Irakia Helen et al. 4 has explained about PST and CLEHI for enhancing the visually impaired images and performances compared with Sobel edge detector. Shanto Rahman, M. D. Mustafahur Rahman, M. Abdullah Al-Wajid, Ghulam Dastigar Al-Qadri, and Mohammed Shoaib et al. 5 proposed AGC performs in classification of image the contrast level present in the image. The image varied into dark and bright images. 2. Phase stretch transform. The phase stretch transform, PST, is a new computational approach for signal and image processing. PST has roots in photonic time stretch technique and a best method for real-time measurements of ultra-fast events. PST is also optics-inspired algorithm which has superior properties that can be exploited to develop advanced algorithms for feature extraction from digital images. Fig. 1 block diagram of PST. The blocks in PST processing includes A. Image acquisition. The acquisition of digital image is the processes of making a photographic image, for example, physical scenes, or the inside structures of the article. The term is regularly accepted to incorporate the handling, pressure, stockpiling, printing, and show of such image. Contingent upon the kind of sensor, the subsequent image information is standard 2D images, a 3D volume, or an image arrangement. Re-inspecting is performed to guarantee that the image facilitate framework is right. Fig 2 show the input image. B. Image pre-processing. Image pre-processing is the term for task on image at the most reduced dimension of reflection. The IJERT file function is to get the image from the dataset. After getting the input image, the pre-processing step has been performed. In pre-processing, the input image is resized to 512 x 512 sized images for the processing. Fig 3 shows the grayscale image. C.Construct PST. PST is a physics-inspired digital image transformation that emulates propagation of electromagnetic waves through a diffractive medium with a dielectric function that has warped dispersive property. PST has. Fig 2.5 Overlay image. After the edge detected using PST, an overlay is created by using edges detected by PST. Fig 5 shows overlay image. The overlay image and input are fused together. Complement, haze has been reduced and complement is done. High boost filter used for further enhancing the image. High boost filter is used for further enhancing the image. Fig 6 image with PST and high boost applied. High boost filter is used to enhance high frequency component while keeping the low frequency components constant. Fig 2.6 shows the enhanced image with high boost filter. 3. Adaptive gamma correction. Adaptive gamma correction is a contrast enhancement technique. Contrast is the difference in luminance or color that makes an object, or its representation in an image or display, distinguishable. The existing contrast enhancement techniques can be categorized into 3 groups: global, local, and hybrid techniques. Hybrid enhancement techniques comprise of both global and local enhancement techniques. A. Flow chart of the AGC. The main objective of the AGC is to transform an image into a visually pleasing one through maximizing the detail information. This is done by improving the contrast and brightness without incurring any visual artifact. Fig 7 shows flow chart of the model. Fig 7 flow chart of the AGC. B. Color transformation. Several color models, such as red, green, blue, RGB, lab, HSV, and YUV are available in the image processing domain. However, images are usually available in RGB color space where the 3 channels are much correlated. And hence, intensity transformations done in the RGB space are likely to change the color of the image. For AGC, project adopts HSV color space, which separates the color and brightness information of an image into hue, H, saturation, S, and value, V, channels. HSV color model provides several advantages, such as having a good capacity of representing a color for human perception and the ability of separating color information completely from the brightness, or lightness, information. Hence, enhancing the V channel does not change the original color of a pixel. C. Image classification. Every image has its own characteristics, and the enhancement should be done based on that. To appropriately handle different images, the proposed AGC first classifies an input image I into either low contrast class Q1 or high, or moderate, contrast class Q2 depending on the available contrast of the image using EQ. Fig 8 Image classification. D. Intensity transformation. V. Conclusion. This project proposes 2 different methodologies for enhancing the visually impaired images. Phase stretch transform uses the edge detection for enhancing the image. To detect the efficient features in the visually impaired images, the PST is being proposed to detect the features. But in PST the color images are needed to be converted to grayscale image. Adaptive gamma correction is a simple, efficient, and effective technique for contrast enhancement. AGC has low time complexity and it can be applied in both color and grayscale image. When comparing PST with AGC, AGC has upper hand because it takes less time for execution and no requirement for converting color image to grayscale image. Performance of AGC is better than PST by analyzing the tables. As a future work of this project, the edge detection of phase stretch transform need to be improved.